graphing. And what are the three possibilities for solving by graphing? They are one solution, zero solutions, or infinite solutions. Yeah. So when you graph, if what it'll look like if there is one solution is this. Do you know what this is called in geometry when the lines go like that? When they're not parallel, they are askew, but that's okay. So one solution looks like that. The lines are skew. Skew. Or is it askew? We'll just say skew. Zero solutions. What would the lines look like? They don't ever touch, which is called what? Parallel. Yeah, parallel. Yeah. Parallel. So you should always visualize this whenever you're solving a system of equations, which is two or more. You're looking for the point of intersection. And infinite, what would that look like? Yeah, when you try to graph it, or when you write it in slope-intercept form, you'll get the same equation. So that's how you show that two lines are the same. And that means, so they are the same line. Two lines are the same. So you probably want, be sure you have a straight edge, or if you want to take a second to grab a ruler back there for your team, you can. So on each of these, we're gonna see examples here of each. So let's start with this equation, the first one. How are we going to graph 3x minus y equals 2? Yeah.
Isn't it like you set the first equation so
Okay.
y is alone?
Okay. So you got to get y alone, yeah, which is called slope-intercept form. So you solve for y, so you basically subtract 3x from each side. And then you divide by -1. And that flips the sign. So you get y equals 3x minus 2. So that's what you're graphing for the first equation. For the second equation, when you solve for y, you just subtract x. And so that's what you're graphing. So they have to be in slope-intercept form. And then just a reminder, this is how you graph it. So you start at -2 on the y axis, and then you go up 3 to the right 1. So you start down 2, up 3 to the right 1, and you could keep making points. If you don't have a ruler, I would just recommend, and notice you can go in the opposite direction as well. You can go down 3 to the left. And just make sure that if it has positive slope, that the line goes up. You have to graph it fairly carefully. And then the other one starts at 6 on the y-axis and goes down 1 to the right 1. And oh, there we go. So there's that. And so now unfortunately, some students leave this as their answer when it says find the solution, and that they think that this is the answer, but it's not the answer. What is the answer? Good. It's this point right here. It's the point 2,4 where the lines intersect. So don't forget that is your answer. That's why you graphed it in the first place. So let's try this one. For this equation, to solve it, you would just subtract 3x. You get -3x minus 2. For this equation, you would subtract 6x. You get minus 6x plus 10, and then divide by 2. So there's our two equations. So the first one, when I graph it, I start at -2, and I go down 3 to the right 1. But if I didn't have room, I could go up 3 to the left 1. It still has a negative slope. So there's that. And then this one, you start at 5, and you go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. So what's the solution? Yeah, and you should see by looking at the equation, see the slopes of -3 and -3? Same slope, right? So you still need to graph it, but you should know ahead of time that you're going to end up with no solution there. No solution. And the last one is so you subtract x from each side, and then you divide by 2. So -1/2 x plus 5/2. For this one, you divide everything by -6. So you get y equals -1/2 x plus 15/6, which is the same as 5/2. So we know the answer is, well, let's see. If we graph, they're both the same, right? So when I graph it, I put my y-intercept at 2.5 because that's 5/2 is 2.5. Sometimes decimal form is easier, 2.5. And then from 2.5 on the y-axis, you go down 1 to the right 2, down 1 to the right 2. And so we would be graphing the same line twice. The way you show a line on top of each other is just put another set of arrows on it so it looks like there's two. They both go on forever though. So the solution is, there's too many to list. It's infinite solutions. They intersect everywhere. So we just say there's infinite solutions. So that is that.